We're starting off now with a new topic, which is perception. Most work on perception has been done on vision, and that's an unfortunate bias, but we will, for that reason, concentrate mostly on vision. There are mysteries in the study of perception. It's not a well understood area, and there are multiple competing frameworks. We'll find a lot of work within computational theory of mind, but we'll have reason also to suggest that the questions that come with perception open up into areas that we're going to need very many different kinds of theoretical approaches if we're ever going to understand them. So here's a little story that we start off with. We're all told as kids that we have 5 senses: seeing, hearing, touch, taste, and smell. And those act as inputs, and they pick up information about the world, which then goes into the brain. Now that's a sort of a child's version of the computational theory of mind. And when we start to unpack it, it falls apart. We have to regard that as that's not an accurate picture. It's fine for everyday talk. Most people don't have to worry about the details here, and it provides us with a way of intelligibly talking about seeing, hearing, tasting, smelling, and touching. But when we look at the details, as we must as scientists, we find that there's lots of room for improvement on this story, and that any plausible story will turn out to be much more complex than this. So underlying that simple story is a simplistic view of the nervous system, by which the nervous system is seen as if it was distinct from everything else, and that sources of information in the world, like patterns of changing light or vibrations in the air, which we're going to hear, impinge on the nervous system at certain points in the body. In the retina for the eye, in the inner ear, in the cochlea for hearing, on the skin for touch. You get the idea. So those points at which energy can impinge on the nervous system, that's where we find receptors. And we find receptors in the inner ear, and we find receptors in the retina, and so on. But we don't find 5 simple different kinds of receptors, one for each sensory modality. The situation is, of course, much more complex. With regard to the 5 classic senses, in vision we're going to find multiple receptor types on the retina, which pick up or are sensitive to different kinds of information. We'll get to that. In audition, in hearing, we find receptors in the inner ear, so the story still works fairly well for that. In touch, as we'll see, though, we find many different kinds of receptors which are sensitive to such different kinds of information, or maybe not even about information, that we have to regard touch as much more complex. It opens up into many different kinds of things. We'll get to those. Taste and smell are not really separate. You've all had a bad cold at some stage, and when you do, you know that a stuffed nose means you can't really taste things properly, so they're not as separate as we would like. But when we go looking at these receptors, we find them in lots more places. We'll find them in the vestibular system, also in the inner ear, but not connected with hearing, but connected rather with vision and with awareness of movement. And then we find receptors in the muscles and the joints, which are giving us information about the position and movement of the body, but they don't correspond to any of those 5 senses. And then we find more receptors still scattered throughout the guts, in the stomach, in the bladder, giving us information about the body in a way that's very poorly understood, and generally goes by the name of interoception. So, looking at the points where the standard story doesn't work very well, we see that in touch, we gather lots of different kinds of information through our skin. So we're sensitive to heat. We have receptors which are sensitive to hot and cold. These are thermoceptors, and you know you don't have to put your hand into the fire to feel that the fire is warm. So that's obviously completely different from those receptors which require contact. And for those, there are at least 3 different kinds. Receptors sensitive to stretching of the skin, to vibration, and to pressure. Very different kinds of information. And then there's receptors where the information processing vocabulary just breaks down. They are receptors, and they cause an awful lot of activity in the nervous system, and they somehow connected with our awareness of pain, nauseous. You feel pain, you perceive pain, but pain is not very specific information. It's often very difficult to figure out what pain is about in any sense. It's more like an alarm signal. So those receptors don't really fit the model of 5 input channels, gathering information about the world. There's the vestibular system in the inner ear in all its glory. The cochlea is there, that's connected with hearing. We'll leave that to one side. The 3 large loops are at right angles to each other, one up, one like this, one like this, and they're fluid filled. These are the semicircular canals. Because they're fluid filled, they can register acceleration of the head. As your head is jerked around, that's picked up here. That works closely with the eyeballs to disambiguate a lot of what you're seeing. Maybe you've had this experience in a train once. If you're in a train at a station, the train is stationary, and there's another train beside you and it's also stationary. And you're bored. And after a while your train starts to move, and as trains do, it moves slowly. And just as you're expecting to leave the other train behind, you suddenly, with a shock, realize it was the other train moving and not yours. You're still sitting there. Has that ever happened to you? It doesn't happen on buses. Why would it happen on trains and not on buses? The answer is in the semicircular canals. Trains are very, very heavy. They don't accelerate strongly at all. They move very slowly. They take off very slowly. So there's no information coming from the vestibular system to tell you whether the change on your retina has its origin in your movement through space, if your train is moving, or in something else moving through space. So that disambiguation role is provided by the vestibular system. Now, we find receptors, as I said, in the muscles and in the joints. Proprioception refers to the sense we have of where our body is in space. Are your hands up or down? Are your legs folded? How are you positioned in space? As with any sensory modality, sometimes if you want to know where your leg is, you've got to move it just a little bit to find out. So change is always going to be underlying all perceptual systems. Receptors only respond to change. But as well as knowing where we are in space, we also have an awareness of our movements through space. Kinaesthesia, might be the primary sense of the dancer, is an awareness of how your body moves through space, how it twists and turns and bends. Both of these sensory modalities are linked to receptors in the joints and the muscles, and they don't fit any of the 5 classic sensory modalities. And then I said, here's one we know very little about, interoception. You become aware that you need to use the loo, or that you're nauseous, or that you're hungry. And these are all awareness of states of the body, which connect to the nervous system, otherwise you wouldn't become aware of them, through receptors, but receptors diffusely scattered throughout the viscera, throughout the body. So it's definitely not one simple sensory modality, and we understand this rather little. So I said the simple story that we learned in school about 5 input channels doesn't hold up to scrutiny if we treat it in that simplistic way, as if an input channel was where the nervous system became aware of things through a specific kind of receptor. It's more complicated. That's not surprising. But there's another reason to be suspect about that story. It treats the person as if they were passive. And in fact, as I just mentioned, all perception is based on change, and a lot of that change is change you make yourself. You move your eyes, as we'll study in some detail, you move your head, you move your hands to see things. Audition doesn't seem to involve so much movement, but it tells you an awful lot about where you are in space. So we come to know the world in an active manner. And as we'll see, different theories take differing accounts of activity here. But perception, coming to know the world, is not a passive process. It's something that we actually do in the dance of the body with the world.